In this video, I'm going to do a quick review on multiplying polynomials. So let's start off by multiplying a monomial times another monomial. So this would be a good time to explain once again what a monomial is. Well, a monomial is something such as 3 times x squared. There is no addition, there is no subtraction, there is no division, simply multiplication of numbers and variables. So 3x squared is a monomial. And another example of a monomial would be something such as 2x to the 5th. Once again, there is no addition or subtraction, there is no division. It is simply multiplication of numbers or constants times variables. Those are monomials. So we are multiplying two monomials together here. So the way that we multiply two monomials is to multiply the coefficients or the numbers. 3 times 2 would be 6. And then we multiply the variables. So we only have one variable, x, and x squared multiplied by x to the 5th. We add the exponents because we are multiplying the x's, which are called the base, and so we get 6x to the 7th. Another example of multiplying monomials would be something like negative 3z to the 5th times 5z to the 4th. Once again, we have two monomials. We multiply the coefficients together. Negative 3 times 5 is negative 15. And then we multiply the bases, the z's. And so to multiply the bases, which is z, we simply add the exponents. Now, if you need a good review of how to multiply these bases, see my video on the exponent rules, where I do a quick review of your exponent rules. And this rule is basically when you are multiplying similar bases, you add the exponents. Let's do one more. Let's say we have 3x squared y times 8xy cubed. Well, we simply multiply the constants or the coefficients. 8 times 3 is 24. And now we have two different bases. So we multiply the x's together and we add the exponents to get x cubed. And we multiply the y bases and we add the exponents to get y to the 4th. So that is multiplying two monomials together. Now, we could also multiply a monomial. Let's say we had 2x to the negative 2 and 9x to the 7th. Well, we have a negative exponent here. Once again, you might want to take a look at my video, quick math video on exponent rules. But 2 times 9 is 18, and we don't do anything different. We're simply multiplying the bases and we add the exponents. Okay, now let's get into multiplying a monomial times a polynomial. So a monomial times a polynomial or many polynomial. In other words, poly meaning many. We have many terms or monomials being separated by addition or subtraction. So an example of a monomial, once again, would be 8x squared. And a polynomial might be something like x squared plus 2x plus 3. This is a trinomial because we have 3 terms. Each monomial term is, there's 3 different monomial terms, x squared, 2x, 3, and we're adding them together. So many terms, many monomial terms, but because there's 3 of them, we call it a tri for 3 nomial. Well, we use the distributive property to multiply this. For the good old distributive property. And we take the monomial and simply multiply it by each term. So 8x squared times x squared would be 8x to the fourth. 8x squared times 2x would be 16, and we add the exponents, x cubed. And then 8x squared times the 3 would be 24x squared. And so that is the distributive property. We simply take the monomial term and multiply it by each term in the polynomial. One more, negative 4z squared times 2z cubed plus 3z. So this is a polynomial, but specifically it is a binomial, bi meaning two. There are two monomial terms being added together, so it is a binomial. Well, we're going to use the distributive property, just like we did in the previous example. Negative 4z squared times 2z cubed would be negative 8 times z to the fifth. And then negative 4z squared times 3z is going to be what? A negative 12z cubed. Let's multiply two binomials. A binomial times a binomial. Something such as, let's make it fairly simple, x plus 2 times x squared minus 3. These are both binomials, and we are multiplying them together. Well, once again, we use the distributive property, and we take the first term in the first binomial and multiply it by each one. So the x gets multiplied by the x squared, and so we would get x cubed. Then we take the x and we multiply it by the next term, which then would be minus 3x. Then we take the inside, this or the 2, and multiply it by the x squared, and we get 2x squared. And then we take the 2 and multiply it by the minus 3, and we get minus 6. Now, to help us remember that, there's a nice little acronym, FOIL. So sometimes this is referred to as the FOIL method for first, outside, inside, and last. So what I did here was I multiplied the first term in each. Then I multiplied the outside terms, the x and the minus 3. The inside terms, the 2 and the x squared. And then the last term in each binomial, the 2 and the minus 3. Let's do one more. Let's take x plus y times z plus 3. And yes, let's use the FOIL method. So the first term in each would be x times z. The outside terms would be x times 3. The next term would be the inside terms, which is y times z. And then the last term in each would be 3y. And now there's no similar terms to add together there, so that would pretty much be it. Now, if we're multiplying two polynomials together, a polynomial, well, two binomials is really a polynomial times a polynomial. But what if they're bigger polynomials? Polynomial times a polynomial. So what if we have something like x squared plus 2x plus 3 times 5x squared plus x minus 1? Well, we simply use the distributive property. We start with the first term here and multiply it by each term in the second trinomial. So it's a trinomial times a trinomial. So x squared times 5x squared, we would get 5x to the fourth. That's this times this. This is going to get kind of messy if I'm not careful. Then the x squared times the second term. is going to be x squared times x, or x cubed. And then the x squared times the minus 1 is minus x squared. Then going to the second term, 2x, I'm going to do that above here, 2x times the 5x is 10x cubed. 2x times x will be 2x squared. And then 2x times the minus 1 would be minus 2x. And then finally, the third term in the first polynomial times each term in the second one. So 3 times 5x squared would be 15x squared. 3 times x is 3x. And then 3 times the minus 1 would be minus 3. And that is multiplying those two trinomials. We end up with a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 different products because we're multiplying a 3 by a 3, and 3 times 3 is 9. Now we can add some of these similar terms together. 5x to the fourth, there are no similar terms. X cubed and 10x cubed is 11x cubed. And then minus x squared plus 2x squared is an x squared. X squared and 15x squared would be 16x squared. And then finally, a minus 2x and a 3x would be x, and then minus 3. And so we generally like to write polynomials in descending power of the variable, x to the fourth, x cubed, x squared, x, and minus 3. All right, let me just give you a couple exercises real quick to do. As always, stop the video, do the exercise, and then compare, see how you did. So number 1, let's multiply 3x squared times negative 8xy cubed. Number 2, let's multiply x squared plus 2 times 3x cubed minus 4x. Let's throw in a negative exponent to the negative 3. And the third one is going to be 2x to the negative 1 plus 3x to the negative 4 times x to the negative 5 plus x to the negative 6. Stop the video and then start. All right, let's see how you did here. So for this first one, we have a monomial times a monomial. So we're going to simply multiply the coefficients. 3 times 8 is a negative 24. X squared times x would be x cubed. And then there's nothing to multiply. There's no y over here. So we simply bring along the y cubed. And there is our answer. For the second one, we're going to use the distributive property. X squared, the first outside, inside, last. So the first term in each, x squared times 3x cubed, is going to be 3x to the fifth. We are adding the exponents. The first times the last, the outside ones, is going to be a negative 4. And an x squared and x to the negative 3 is going to be, we're adding the exponents, x to the negative 1. The inside terms, we will have 6x cubed. And then the last term, the 2 times the negative 4 is going to be a negative 8. Need a little bit more room here. We're going to have a negative 8x to the negative 3 minus 8x to the negative 3. Now, if you watched my video on the exponent rules, you know that we could also write this then as 3x to the fifth minus 4 over x plus 6x cubed minus 8 over x cubed. And then finally, the last one, lots of negative exponents. We're multiplying two binomials, so we can use the FOIL method, first, outside, inside, last. So multiplying these two, the first term in each, we have 2x negative 1 plus a negative 5 is a negative 6. The outside terms, we will also have a 2. Adding the exponents, we'll have x to the negative 7. Now the inside terms, we will have 3x to the negative 9. And then the last term in each, we will have a 3x to the negative 10. 6 plus 4 is 10. And then, of course, I could write this as 2 over x to the 6th plus 2 over x to the 7th plus 3 over x to the 9th and 3 over x to the 10th. So one last thing I want to mention is, technically speaking, a couple of these problems were not polynomials because they have negative exponents. The terms that have the negative exponents, we're treating them like they were polynomials, but technically speaking, with a negative exponent, it is a rational function, not a polynomial. But for the purposes of this video, it really doesn't matter. So that's that. Hopefully this was helpful.